Enzymes generally function in a narrow range of temperature and pH. We say is optimum temperature and optimum pH. Its highest activity at a particular temperature and pH called the optimum temperature and optimum pH. The highest activity. When activity declines both below and above the optimum value, low temperature preserves the enzyme in a temporarily inactive state, whereas high temperature destroys enzymatic activity because proteins are denatured by heat. Now, concentration of substrate, how it affects the enzyme activity. See in the diagram, concentration of substrate on enzyme activity. So on x-axis it is a concentration of substrate on enzyme activity. On y-axis is velocity of reaction. So Vmax gets half of Vmax, tells the Km value. Now you see effect of change in pH and temperature. So you see on x-axis it is pH or temperature, and y-axis it is enzyme activity. So that its activity is highest at its optimum temperature and pH. So these two graphs tells. Now comparative inhibitor. Example is inhibition of succinic dehydrogenase by malonate. Malonate is a substrate which closely resembles the substrate succinate in structure, and the enzyme is succinic dehydrogenase. Now when the inhibitor closely resembles the substrate in its molecular structure and inhibits the activity of the enzyme, it is known as competitive inhibitor. Due to its close structural similarity with the substrate, the inhibitor competes with the substrate for the substrate binding site of the enzyme. Consequently, the substrate cannot bind, and as a result the enzyme action declines. Now classification and nomenclature of